At the Melanti Junction, the design safety for Melanti Junction is vulnerable road with the infrastructure, speeding, alignment and geometry layout.
Hi everyone, so today we are going to present our road safety audit inside our campus. Two locations have been selected, which is the first location is at the Melatiti Junction, and another one is at Bukit Tonggek. So today we're going to talk about Melatiti Junction. At this Melatiti Junction, this is one of the busiest intersections, and the first major issue we identified here is the chronic double parking, as you can see here. Alright, okay, because of the lack of nearby parking spaces, as you can see on top, the parking spaces is very full, which causes the double parking issues occur here. And also, because of the double parking issues, this has causes the traffic to merge into narrow one single lane and severely blocks the sight distance for drivers to trying to exit at the junction safely. As you can see here, this is one of the major problem for the double parking issues. Okay. Alright, so one of the solutions that we recommended here is we need to install the double yellow lines, and also another recommendation is we can install a no parking or no double park or towing zone sign, which is at the junction approach, so that this will prevent the drivers from blocking the lanes and restore proper visibility for the turning vehicles.
Okay, so moving on to the second critical issues at Melanti Junction, which is jaywalking. We observe a high volume of students crossing the road at non-designated areas right within the junction conflict zone. So, as you can see, which is because there are no physical barriers to stop them. When students take shortcuts to cross, forcing the oncoming vehicles to brake abruptly. So this creates an extremely high risk of pedestrian vehicle collision. So we propose solution for this issue are twofold. First, we need to construct a designated zebra crossing, of course complete with advanced warning signs. Second, we should install pedestrian fencing or barriers along the walkways. This will physically prevent students from jaywalking and safety guide them to use the designated crossing zone.
The junction capacity and level of service, or LOS lab, is directly related to this RSA because it measures traffic volume, delay, queue length and intersection performance using traffic surveys and Sidra intersection software. These results help us identify operational problems and evaluate whether the proposed engineering improvements will reduce congestion, improve traffic flow, enhance visibility, and ultimately create a safer junction with a lower crash risk.
Evaluate the operational performance of Melanti Junction. A junction capacity and level of service analysis was conducted. A traffic counter or tally sheet was used to record the traffic volume and turning movements at the junction. Traffic data were collected at 5-minute intervals over a 1-hour observation period to capture variations in traffic flow. A stopwatch was used to ensure that each 5-minute interval was accurately timed. A mobile phone was used to record the traffic conditions for verification and future reference, while safety vests were worn to ensure the safety of the survey team during data collections. Finally, the collected traffic data were entered into Sidra intersection software to analyze the junction performance, including vehicle delay, queue length, and level of service. This analysis was conducted to determine whether the safety issues identified during the road safety audit, such as double parking and unsafe pedestrian crossings, were caused by insufficient junction capacity or by other operational and road design factors. The collected traffic volume data were analyzed using both manual calculations based on the ATJ 11/87 Pindaan 2017 method and Sidra intersection software. The results indicate that the junction operates at LOSA and LOSB with relatively low average vehicle delays. Although slight differences exist between the manual and software results, both analysts show that the junction has sufficient traffic capacity. Therefore, the road safety issues observed during the site inspection, including double parking and pedestrian conflicts, are not primarily due to congestion but are more closely related to driver behavior, roadside activities, and the existing road design.
Now let's move on to our second hotspot, which is the steep hill of UiTM, which is called the Bukit Tonggek. We can see the condition of the road with the uneven patches, which is become an issue for the user for braking on downhill. To make things worse, we can see there is no road marking at all, and then there is no line edges to mark where the road width is. So it must be confusing for the drivers to drive with the right lane. To make things worse, we can see there are signs of no entry, but still, they are using this road. There is also no street lighting. Even though they have installed few street lighting, it is not working at night, which leaves the steep hill pitch black at night. Vehicles swerve. There are no guardrails installed. Instead, there are drainage at both sides of the road, which can cause accidents. As you can see, they also installed a rigid water hydrant at the right side of the road, which can cause massive collision with the vehicles. To back this up with data, our group have conducted a spot speed study on this hill. We found that vehicles are hitting almost 43 km per hour on this hill, while 43 km per hour sounds normal elsewhere, but on this steep hill and narrow hill at the campus, with the uneven condition of the road surface, it is very highly dangerous and significantly increases the braking distances. In terms of traffic control, this Bukit Tonggek is supposed to be one-way downhill road only for light vehicles. However, we observe major issue. People are constantly parking at the roadside, even though there are no designated parking spaces, can cause the road is to be narrow. Even worse, we got a heavy lorry driving down this Bukit Tonggek and van driving up against the road. You can see there is the sign and there is no entry to the road. Based on our road safety audit RSA, here is the summary of this and our injury recommendation for this Bukit Tonggek. The first one is missing road marking, zero street lighting, poor patches pavement, illegal roadside parking, heavy vehicle, upstream traffic. So for the next is high risk of head-on collision, side swipe due to block visibility, and severe impact injury if vehicle plunge into the deep drain or hit the rigid hydrant. So for the recommendation, first is paint double yellow or red line along the road edge to strictly enforce a no parking zone. Repaint all edges line and directional arrow using thermoplastic paint and install clear one way only and no heavy vehicle side. And next is install solar LED, street light and safety guardrail on both sides of the slope. Resurface the road and relocate or shade the water hydrant.
This spot speed study was conducted to measure the speed of a vehicle at a selected location using a radar gun. The purpose is to establish the speed distribution of a traffic stream at Bukit Tonggek. And next is to determine the vehicle speed percentile via speed trend analysis. And lastly is evaluate a road safety audit RSA at Bukit Tonggek. And we know that the issue at the Bukit Tonggek is poor road condition, no road marking and line edges, no entry sign, no damaged street lighting, no guardrail and unprotected drainage, and lastly is unprotected roadside hazard. And we recommend that paint double yellow or red line along the road to prevent illegal parking. Next is repaint the road marking and add clear one way and no heavy vehicle sign. More than that is install solar street light and safety guardrail along the roadside. Last but not least is resurface the road and relocate or protect the water hydrant. And while we conduct this lab, we need radar gun, walking measure and data form. And the procedure is, first we have a position the observer at a safe location and set up the radar gun before starting the lab. And next is aim the radar gun at an approaching vehicle and pull the trigger to measure its speed. Ensure the radar gun is pointed directly at the vehicle to obtain an accurate reading. Lastly is record the speed display on the radar gun and repeat the measurement for each passing vehicle for 20 samples. Here is the result and analysis for spot speed study while we conduct at the Bukit Tonggek.
Therefore, our recommendation is to install traverse rumble strip and reduce speed warning sign right before the crest of the Bukit Tonggek. This will give driver a physical and visual alert to slow down to a safe campus speed limit of a 30 km per hour